All
Uh,
right, let me go ahead and start sharing my screen.
yeah, you are the host right now, ma'am. You are good to. We are
Yes,
good to go. Thank you.
perfect. Let me open up my presentation. Okay, and now I'm going to put it in PowerPoint mode. Perfect. Can you see my screen?
Yes, from my end, but if anyone, any other participant could have vouched for it, it would be great. Yeah.
Yeah. All right, everybody. So I have the privilege through Advantage India to talk about mastering artificial intelligence without any coding. And I'm going to give just whet the appetite on what this 4-day course will be. And I highly suggest you sign up for the course because there's going to be a lot of unraveling of the black box, and there's going to be a lot of focus on just truly learning about artificial intelligence. That way we can communicate effectively on what artificial intelligence is doing. And you don't have to learn, like do actual coding. You need to be an expert end user and use expert prompt engineering in order for you to do well with artificial intelligence. So let me change my slides. Perfect. I want everyone in the chat just to type in their name, affiliation, experience with AI. What would you like to get out of the class that's going to be hosted in the next couple of weeks? And your favorite cuisine to eat. So I'm going to stop sharing I'll keep my screen, but let me see in the chat if there's anybody that can type in the chat their name, affiliation, experience with AI, and what you'd like to get out of the class, and what's your favorite cuisine to eat. So I would just want to know where everyone is tuning in from. And I'll give a minute for people to do that. Looks like the chat is quiet, so what I'm going to do is I'm just going to keep moving on. I want to excite you guys in terms of the course because the table of contents is going to be the course objectives. And then we're going to talk about the focus of this webinar is just going to be about like what is artificial intelligence. We'll talk about the black box models, productivity tools and AI platforms, technical writing and reporting, searchability, simulation and field optimization, STEM and education outreach, all of course, the ethics, IP, and responsible use of AI, and then capstone exercises. So for the course objectives, for those of you, you should sign up for the course. Identify high impact tools for oil and gas workflows. Apply generative AI to oil and gas reporting, communication, and technical applications. Automate repetitive tasks to improve productivity and clarity. Give me 1 minute. And then build AI enhanced deliverables for technical applications and understand practical and ethical boundaries of AI. So what is AI exactly? There's a visual for this, but let's start with some definitions. Artificial intelligence is the computer systems designed to perform tasks that typically require human intelligence. It enables machines to learn from data, make decisions, solve problems without being explicitly programmed for every scenario. AI includes a range of technologies like machine learning, natural language processing, computer vision, and generative models. Machine learning is a subset of AI where algorithms improve performance by learning patterns from data over time. Natural language processing allows machines to understand, interpret, and generate human language. So that's used in chatbots, search engines, and document summarization. So that's also used in ChatGPT and Copilot, Grok, Claude, you name it. And then generative AI. Like, what do we mean when we say generative AI? Creates new context, text, images, code, or simulations based on learned patterns. So that's ChatGPT, Copilot, and then DAL-E. AI systems can be rule-based, so following program logic, or adaptive, so learning experience and feedback. In oil and gas, AI is used for reservoir modeling, production forecasting, drilling optimization, and technical documentation. AI enhances productivity by automating repetitive tasks, extracting insights from legacy data, and enabling faster decision making. It's not magic, it's math, data, and smart design working together to simulate intelligent behavior. Responsible AI use involves transparency, data, ethics, and human oversight to ensure accuracy and trust. AI is a tool, but it's not a replacement for human expertise. It amplifies what we know and how fast we can act. So now you hear all these words. You hear AI, you hear machine learning, you hear deep learning. So, what exactly is all those things? So, AI, a broad field focused on building systems that mimic human intelligence. It encompasses reasoning, learning, perception, decision making, and language understanding. It includes rule based systems, expert systems, robotics, and learning algorithms. Key characteristics can be symbolic, logic based, or statistical, data driven. Learning and non learning systems, so it includes both. Examples are chatbots, autonomous vehicles, smart assistants, expert systems. And then for oil and gas applications, field optimization, smart drilling assistance, and ESG reporting automation. Then you have natural language processing for summarizing technical reports and legacy data. Then you have machine learning. Machine learning is a subset of AI, and it's focused on algorithms that can learn patterns from data without explicit programming. It improves performance over time through experience and feedback. Key techniques for supervised learning, like predicting well productivity, unsupervised learning, unlabeled data, clustering reservoir zones, reinforcement learning, learning through trial and error, optimizing lift strategies. And then key characteristics, it requires large, clean data sets. Outputs are probabilistic, not deterministic. Examples are predictive maintenance, anomaly detection, production forecasting. Then for oil and gas applications, you're thinking at ML models for equipment failure prediction, well ranking, and CO2 injection optimization, clustering subsurface data for facies classification and reservoir characterization. Now we're going to have deep learning. So you've heard about deep learning too. So it is a subset of ML that uses multi-layered neural networks to learn complex patterns inspired by structure and function of the human brain. So you have convolutional neural networks, image and spatial data, recurrent neural networks, time series and sequential data, transformers, language modeling, and document summarization. Key characteristics is it requires massive data sets and high computational power. It excels at unstructured data, images, audio, and text. And examples are facial recognition, speech to text, and then document summarization. For oil and gas applications, deep learning for seismic interpretation, image-based core analysis, and dynamic reservoir simulation. NLP models for summarizing ESG reports and technical documentation. So here is just a table that I'll make you guys like look into a little bit, like AI, ML, and deep learning. You have the broadest, which is AI, and then within the circle you have ML, and then within that circle you have deep learning. So this is everything that we just talked about in written form. So how are we already using AI? This is nothing new to us. We have Siri, like assistants like Siri, Alexa, and Copilot. We have email filtering, like detecting spam, prioritizing important messages, suggesting replies in Gmail and Outlook, streaming recommendations, navigation and traffic updates, online shopping, social media feeds, banking and fraud detection, healthcare diagnostics, language translation, facial recognition, customer support, job matching and resume screening, smart home devices, and document summarization. So I'll give you guys a moment to just read a little bit about this, but we're already using artificial intelligence. This is nothing that we should be scared about and thinking that AI is going to take over the world. We've always been using it, and it's been evolving for quite some time. So here is some of the reasons why people are scared of using AI, or there's AI resistance. Fear of job displacement, lack of understanding, data privacy concerns, loss of control, cultural resistance, skill gaps, ethical ambiguity, overhyped expectations, integration challenges, security risks, lack of leadership buy-in, and fear of creativity loss. So there's an irony that AI will dilute human intuition, originality, or craftsmanship. For job displacement, like there's a lot of repetitive tasks that AI can do very quickly, and that can replace a human being rather than augment the human being's job. There's also cultural resistance, organizational inertia, and skepticism towards new technologies, especially in legacy industries. So how can we be less resistant to AI? This course is going to help you with this because we'll start with education. We learn the basics of AI, what it is, what it isn't, and how it applies. Focus on augmentation, not replacement. Use low-risk tools first. Pilot AI in real workflows. Encourage curiosity over fear. Provide training and support. Celebrate quick wins. Clarify boundaries. Involve stakeholders early. Model adoption from the top. Address ethical concerns and transparently, and then make AI visible, not invisible. So now I'm going to talk about how AI has actually been a part of our lives for quite some time. So here's the history of AI in oil and gas. It goes back all the way to 1950 on laying the groundwork for machine intelligence. Then artificial intelligence was coined as a term in 1956. And that was initiating formal artificial intelligence research. 1960s and 1980s, it was a largely academic topic. Early expert systems and rule-based logic begin to influence industrial automation, like basic control systems and refineries. And then AI enters industrial automation. Oil majors begin experimenting with neural networks for seismic interpretation and reservoir modeling. Then you have fuzzy logic in the late 1990s and early machine learning algorithms applied to drilling optimization and fault detection. And then in the 2000s, you start having SCADA systems, integrating basic AI modules for real-time monitoring and control pipelines in production facilities. And then you have data-driven exploration and production in the 2010s, AI deployed for seismic and data analysis, faster, more accurate subsurface imaging, machine learning models for reservoir and production engineering. Predictive maintenance becomes mainstream, reducing downtime, natural language processing. Then you have large companies like BP, Shell, and ExxonMobil investing in AI startups and internal platforms to accelerate digital transformation. And then you have AI operationalization and strategic integration. COVID-19 accelerates remote operations. AI supports virtual inspections, remote drilling analytics, and automated reporting. And then AI-powered digital twins simulate the entire fields and facilities for scenario planning and emissions tracking. Reinforcement learning is tested for autonomous drilling and well control. AI begins to support ESG reporting, carbon accounting, and methane leak detection. And then you have generative AI and legacy data transformation. Generative AI tools like ChatGPT and Claude are integrated into technical writing, rapid synthesis of field reports, and regulatory filings. And then AI validation workflows, detecting hallucinations. And we'll learn what hallucinations mean in the course, especially critical safety and compliance contexts. And then, as of now, AI data centers are powered by natural gas, present new synergies between energy infrastructure and digital innovation. Commercializing archives. AI-driven curriculum modules and educator training programs expand energy literacy and technical outreach in emerging markets. So this shows you that there has been a progression of AI, but it's always been there. And to conclude this part of the presentation, again, to whet the appetite, I'm going to talk about the future of AI in oil and gas. You have the strategic implications for the future. We always talk about the energy transition. AI is central to CCUS modeling, carbon trading platforms, and life cycle emissions analysis. Workforce transformation. AI augments technical roles, enabling upskilling and democratizing process to subsurface expertise. Policy and ethics. Responsible AI frameworks are being developed to ensure transparency, reliable, and equity in deployment. And then I will leave talking about unraveling the black box to the course. But I just wanted to provide this webinar to everybody to whet the appetite to be excited for the AI course that I'm about to be teaching in the next couple of weeks. So I strongly suggest you apply for the course. It's an 8-hour training. There's over 200 slides worth of information and exercises to get us to become AI experts and prompt engineering experts. So I strongly suggest you take advantage of the course and let me know if you have any questions. I'm open for questions. Does anyone have any questions? Well, if no one has any questions, I'll hand it back to Advantage Learning.
Yeah, thank you for the wonderful webinar, ma'am. Since nobody have any question, I hope they are pretty much clear with your session. And thank you for delivering the wonderful session. And thank you all for joining from different parts of the world, uh, blocking your time and calendar and making efforts to be here. So if that is done, I think we are good to wind up. If with your permission, ma'am.
Sounds good. I hope everyone has a good morning, afternoon, and evening.
Yeah, thank you. So thank you once again. Bye.
Bye.